Hello. The purpose of this video is for you to do these two things, read and write. And by read, that means when you look at this, you're going to be able to understand what it means, and particularly what these numbers mean, what this letter means. All right. And to write them is if you were given any information about an isotope, you could write this out. You could write it both in nuclear notation and in hyphen notation. Now, to do these correctly, you're going to have to be able to use a periodic table. All right, you can type one in the internet, but you're going to need one. Now, nuclear notation looks like this, where you've got a symbol, all right, it's a letter from the periodic table, and it's either going to be one or two letters. Some elements have two letters and some have one, and then there's going to be numbers preceding it. This top number is the mass number. It's the number of protons plus the number of neutrons. Sometimes there's a number written right here, all right? That number would be the atomic number. Sometimes it's not written, because since the symbol is oxygen, it's understood that the number is 8, because there's only one atomic number for oxygen. So sometimes you're going to have to use a periodic table to fill in a number, all right? This is scandium. Here's scandium on the periodic table. So if you ever wanted to know what this atomic number was, you'd have to read it off the periodic table. And you'd look at scandium's box, and there's scandium's box. Here, it's like blown up. You're going to read it. The atomic number is typically the whole number in the box, all right? So that's a 21. It's there, 21. All right, now, so just to recap, nuclear notation can look two ways. You can either write the atomic number in or not, all right? You need the mass number, because that's the whole point of it. Now, the other notation is hyphen notation, and hyphen notation is where you've got a symbol for an element and then a mass number, all right? Now, to practice this, we've got this, neon 22. So to put it into nuclear notation, I'd simply take the mass number, which in this case is 22, and I'd write it like this. All right, now the mass number for this one is 22. Now to find the number of protons, I'm going to look on a periodic table. I'm going to find sodium. It's right there. There's the number, the atomic number. It's going to be 11. Of 22 minus 11 is 11, and the electrons are going to be the same as the number of protons. Now, here this is uranium, uranium 238, all right? The mass number here is these numbers, it's 238. I'd look up the protons on uranium, it's 92, there it is, all right? So that's this. And then I would subtract 92 from 238 to get the number of neutrons. So 92 plus 8 is 100. 100 take away 238 is 138, plus 8 is 146. All right? So I didn't really subtract by adding. All right? I added, what do I add to this to get to that? All right, now this one's a little different in that I'm given the number of protons and the number of neutrons. So that's going to be 6 because the protons and neutrons are the same. and these are all neutral atoms, all right? And now the mass number is going to be these two added up. So it's going to be 14, all right? And then what I would do is I'd look on here and what's got an atomic number of 6? Carbon. So this is C14 or C14 like that, all right? That's carbon 14, one of the most important discoveries because it allows us to date things, organic things. All right, now, this next one. I'm given the mass number and the number of protons. So to get the number of neutrons, I'm going to subtract. So 40 minus 19 is 21. All right, this is 19. All right, and I'd look on my periodic table. There's potassium. All right, potassium is 19. So this is 40 K or K40, a radioactive isotope found in bananas. Bananas. All right. Now, I've got one more. Now, this one I don't. I've got something with 20 neutrons and 39 a mass number, or nucleons, 39 nucleons, things in the nucleus. So 39 minus 20 is 19 again. Oh, look, they're the same. That means they're the same element. But they'd be different isotopes.